All organic molecules are formed out of a framework of carbon atoms. Carbon enters food webs through producers, which trap CO2 from the atmosphere during photosynthesis. CO2 makes up less than 0.1% of the gas in the atmosphere. Some of the CO2 captured by producers is returned to the atmosphere through cellular respiration, while some is incorporated into their bodies and passed on to herbivores. Herbivores, in turn, return some of the carbon back to the atmosphere as CO2 through cellular respiration, while incorporating some of it into their body tissues. The transfer of carbon continues in much the same way through predators, detritus feeders, and decomposers, until ultimately most of the carbon captured by producers is returned to the atmosphere as CO2. However, some carbon cycles through the environment more slowly. For example, mollusks extract carbon dioxide dissolved in water and combine it with calcium to form calcium carbonate, from which they construct their shells. The shells of dead mollusks often collect in deposits, like these cockle shells on the shores of Shark Bay in Western Australia. Deposits like these are often transformed into limestone, rich formations like those in the Pinnacles Desert south of Shark Bay. As these limestone formations dissolve gradually over time, much of the carbon-rich calcium carbonate finds its way back into the ocean or other bodies of water where chemical reactions transform it into molecular forms that can be used as a carbon source by different aquatic organisms. Another long-term carbon cycle produces fossil fuels, as the carbon found in the organic molecules of ancient plant and animal remains is transmuted by temperature, pressure, and vast expanses of time into coal, oil, or natural gas. Thus, the energy of prehistoric sunlight is trapped in fossil fuels. This energy is released by combustion. So is carbon in the form of CO2. Human activities, including burning fossil fuels and cutting and burning the Earth's great forests, where much carbon is stored, thus increases the amount of carbon dioxide in the atmosphere, which, as we will see later, can have serious consequences for the biosphere.